Hi, welcome to this walkthrough. It is EDEXCEL's mock set 7. It's the foundation paper 2. We've packed it full of methods, top tips, keywords, what you should be looking at, how you should be thinking. Hopefully it will be a really useful revision aid if you are preparing for those mocks or even if you are preparing for the GCSEs themselves. So let's crack on. Our first question. Okay, we're writing this number to the nearest 1,000. A good tip here is to just add those 3 zeros so that you can see which numbers we will be keeping. Is this 5 or more? No, so it's 28,000. Writing these decimals in order of size, one of the things that you can do to help you is to just add zeros so they've got the same number of decimal places. So if you look here, this has got 2 decimal places. So I've added a 0 to get 2 decimal places. But if we look further on, we have one here with 3 decimal places. So that's now what I'm going to do. Okay, I've made them all 3 decimal places. By doing that, it enables me to read this as 600, 40, 520, 167 and 300. And by doing that, it just enables me to see the numbers a little bit easier and put them in order. Write 0.327 as a fraction. Okay, think about your place value grid. We've got our units, tenths, hundred, thousandths. The last digit is in the thousandths column. So that's our fraction. If you're working out a fifth, you are dividing by 5. You may need your bus stop for this. 5s into 9 go 1, remainder 4. Into 43, they go 8, remainder 3. And into 30, they go 6. Okay, we've got to write down the name of the polygon. It's got 1, 2, 3, 4, 5, 6, 7, 8 sides. So it is an octagon. Okay, this question really is just testing whether or not we can use our calculator. So you put it in and you write down your answer. If you were to do the fraction version, that's absolutely acceptable as well. So Kirat is saying that 5 cubed is 125, so 5 is a cube number. And we've got to explain why he is wrong. We're told he is wrong, which means he is. Sometimes I see people go, he's not wrong, but he is. So you've got to think why. And he's just got it round the wrong way. 125 is the cube number, not 5. Okay, we've got a question about how much wool is going to be needed to make a jumper if she changes the type of wool that she's using. So in the first jumper, she used 8 balls and each ball had 280 meters. So if we multiply that through, it will tell us the total number of meters needed for that jumper, which was 2,240. The blue wool has a length of 390 meters. So we're going to take the total that she needs, divide it through by the 390. And we need 5.7 balls. Well, you can't buy, a part. We have to buy in wholes when we're in the shop. So we're going to round that up to 6. Okay, we don't show that time sign. So we'll do the number work we can see, which is 12, and we just squash everything else together. For this one, the 2 will get squashed up next to the M. And because we're multiplying, these M's will come together as a power. We've got 1, 2, 3, 4, 5. So it's to the power 5. Okay, which letter is most likely to be taken? The letter L is most likely because we've got more L's than any other letter. Find the probability that E is the letter. So we've got 1 E, and then we've got a total of 8 letters. So the probability is 1 out of 8. On the probability scale below, mark with a cross the probability that S is the letter she takes. Well, that's impossible because there is no S. And here is a probability scale. The cross X shows the probability of the letter on the card. Now I can see at the 1 out of 4 at the quarter position. So I'm going to go back up to the word and work out which one comes up 1 out of 4. There's 1 out of 1, 2, 3, and count it's 4. There's another 1 out of 1, 2, 3, 4. That's just one way to think about how it works. So it is the letter A. Okay, a suitable metric unit for measuring a pencil would be centimeters or millimeters. So either of those two units would get you the mark. So the price of each pencil in a shop is the same. The price of 5 pencils is 85, and we're being told how much Tyler spends. So we want to know the cost of 1 pencil. 85 divided by 5, which is 17. And then we're going to take the total he spends and divide it by 17, because that's the cost of 1 pencil, to work out that he must have bought 12. Okay, so 10 times 60 is 600, plus the half an hour, which is 30 minutes. So 630 is the answer for that one. So we've got a cake that's going to take 95 minutes to bake. It must be finished at 17:30. So what time should it start? Now, I just do the time backwards, really. I give myself some space because I do literally work backwards. It's going to take 95. So I'm just going to do 60 to start off with, which will take me to 16:30. So I've taken an hour off. Then I'm going to go back another 30, which will take me to 1600 exactly. And I can see here that I've now done 90 of the 95. So I only want to go back 5 minutes. So 15:55 is my final answer. Okay, 275 people took their driving theory test. 68% passed. So the rest didn't. So it would be 100%, take away the 68 to give us 32%. How many of the 275 people who took the test passed? Well, we want to find 68% of 275. Now, you could put that directly into your calculator, but it is a 2-marker. We don't want to risk those marks. So we're going to just set it up as a fraction. Remember, percentage means out of 100. Of means times. And we can just throw that in to get our answer of 187. On Wednesday, a total of 90 people took a practical driving test. Of these people, 72 passed. Now we're being asked to write as a ratio the number of people who passed to those who didn't. So we first of all need to know how many didn't. So we do that first of all, which gives us 18. And then it's passed to fail, if you like. So 72 passed, 18 didn't. And then you can use your calculator to help you cancel that down into its simplest form, which is 4.1. Shape B is a reflection of shape A, and we've got to draw the mirror line. So the mirror line will be absolutely slap bang between them on this horizontal here. So I'm trying to do it nice and thick for you. A circle with a diameter 3 is enlarged. The diameter of the enlarged circle is 15. Write down the scale factor. So scale factor is how many times bigger it is. So 3 times the scale factor gives us 15. So we can see the scale factor would need to be 5. We've been given a triangle, and Phil says that if he drew an enlargement of the triangle with a scale factor of 2, then the angles would basically double. Is he correct? He is not correct, because the angles don't change when you're enlarging. If you imagine my right angle triangle, and let's just say that's side 1, side 2, if I made that twice as big, yes, that would be 2 and that would be 4, but my right angle isn't going to change. It's still going to be a right angle triangle. If that was to double, then it'd be 180 and I'd just have a straight line and the whole thing just would never work. So angles don't change when enlarging. You might have also said that angles in a triangle add up to 180, and these angles add up to 360, which is why it can't be true. So there's more than one way to describe this. Okay, we've got to draw an accurate pie chart for the information we've been given in the table. Now, sport, movie, and documentary all have a chunk of the pie. Pi is a circle, which means the 360 degrees in my circle is going to be shared by the sport, movie, and documentary. Now, we're not going to be dividing through by 3. We're going to be dividing through by the total frequency, because all of these individual people, 8 people like sport, all of these individual people need to be catered for in the pie chart. Now, this adds to 45. So the 360 will be shared by that 45 to give 8. So every single person, every single one out of those 45 basically is getting 8 degrees in the pie chart. So for sport, 8 people getting 8 degrees each means they get a chunk or a section that is 64 degrees big. And then we do the same with the others. Now I know the angle sizes that I need to draw. I will use my protractor. I will line it up along this line that they have given me. I will measure off the 64 degrees, and then I will draw my line through. And then I'll just show you. So let's just say it was roughly here. This is not accurate at this stage. I would then use my new line that I've created to measure the next one. All right, so my 176 would get measured off of this new line that was drawn. Don't go back to the original. Okay, and once you've done that, your pie chart would look like this. Now, you don't have to label the angles, but you can. There's certainly no harm in doing that. But it is really important that you do label through the actual sections, you know, which TV channel does each section represent. Okay, our job is to use the information that we've been given to work out the total weight of 4 small jars of coffee. We've been given information about large and small. So you've got to be really careful that you don't kind of get confused, because it's very easy to do when it's the same thing and the only difference is between large and small. But let's go for it. 5 large jars have a total weight of 1,250. So let's find what 1 is. If I divide through by 5, that tells me what 1 large is. In the next line, I've got 2 large jars of coffee and 7 smalls. And that's got a total weight there. So let's get those 2 large, which is going to equal 500. We're going to take that off of the total, and then we're going to share that by the 7 small jars to work out that a small jar is 100 grams. Now we've got that, we can answer the question. 4 lots of small jars is going to weigh 400 grams. Okay, we're being asked to work out the coordinates of the midpoint. Now, quite often when we see this question, we've got all the grid lines and we've got the axes numbered, and it makes it a lot easier for us to kind of visually see what's going on. This does not make it quite so easy. So actually, we're going to hang on to this keyword midpoint. It doesn't matter whether my midpoint question is related to coordinates, or maybe they're asking the midpoint between 2 fractions. But if you want to get into the middle of something, the exact same process will happen. So the maths to get to the middle or to get to a midpoint is to add and then divide by 2. So what we're going to do is we're going to take the 2 coordinates that we've been given. So we've got -5 and 3. And we've got 7 and -8. and we're going to add them. And then we're going to divide them by 2. And that would be the coordinate of the midpoint. Okay, we've got to draw the graph of y equals 2x plus 4. It's on a calculator paper, so use your calculator. It's just a tool. It's available. You should be using it. If you don't know how, and you need to do it by hand, then I'm going to demonstrate how we get the first couple of coordinates, okay? We've been told that y will equal 2x plus 4. That is 2 times x plus 4. So I'm going to take the 3 off the x-axis, and I'm going to replace the x with that 3, which is going to give me 10. So when x is 3, y will be 10. And I create this coordinate, and I can plot it on. And then I can do 2 next. You'll notice that I'm going kind of backwards along that line. That's because I want to do the positive ones first. Doing positive just makes it easier. And after you've done a couple, you might be able to spot the pattern. It's going down 2, along 2, which means it has to keep doing that because we are creating a straight line. We can't be going off in a funny direction. So you could possibly do the rest of them by this down 2, along 2, down 2, along 2. Once you're done, you just draw your line through. Okay, we're going to cover the rectangle with tiles, and tiles are sold in boxes, and each box will cover 0.8 meters squared. Our units are the same throughout, always worth checking that, which means we can just crack on and go for it. So the first thing I want to know is the area of the rectangle. So I'm going to multiply through base times height. I've got my area. Now I'm going to divide that by the 0.8. So a box of tiles will cover 0.8. How many do I need? Share that in, and it says I'm going to need 13.8. I can't go in and just buy a bit of a box. I've got to buy them in whole boxes. So I'm going to need 14 in total. They cost $19.95 each. So 14 times $19.95 gives us a grand cost of $279.30. Okay, so we've got to draw a sketch of the solid that our plan and our elevations are showing. And we've also got to include our dimensions. So the first thing that we're going to clock is the plan has this line through its center. So something's going on here. It could be a split level, but there's definitely something that I should be maybe conscious of as I'm thinking about this. I'm drawing a 3D shape. It's got 3 pieces of information. So use that to kind of help you realize it's going to be 3D. And the front elevation is probably the best place to start. So I know that it's going to take the shape of a triangle. The side is a rectangle. So I could draw my side off like this. Okay. The plan is kind of the bird's eye view, or imagine the prism just being squashed to the ground. So this here is this one side, and this here is the kind of side we can't see on this left-hand side. So the shape is done, it's drawn, but we do need to get our dimensions on. So check with the squares. I've got 4 going this way, so I'm going to be putting 4 on here. I've got 5 going back that way, which is this direction here. So that's going to be 5. They're centimeters. And then my height is 3 centimeters. Now they only expect in the mark scheme for you to put 2 of them on. So I would mark on as many and as much detail as I can so I don't take any risks. Okay, they're testing your understanding of the word reciprocal. Okay, the best way to think about this is to think of it as a flipping action. This is just going to flip on itself to create 9/2. Whilst we're here, what do you do if you've got a whole number? You just put it over 1 and then you can flip it. What do you do if they've given you a decimal? Well, you can stick that over 1 and then flip it. If you were doing it all by hand, you would then just times this through by 100 to get rid of the decimal on the top. And you've got a top-heavy fraction. In reality, if this decimal was on a calculator, you would put it over 1, stick it in, and the calculator is going to do all the work for you. Okay, write 152 as a product of its prime factors. It's a mouthful, but hopefully we recognize it. And I'll show you why we've got all this language. First thing we're going to do is find factors of 152. So 2 and 76. Don't forget you have actually got your calculator, so you can just do the divide by 2 and find that 76 really easily. Make sure you are using your calculator throughout. And then I'm looking for prime numbers. That's a prime number. So I'm going to ring it. So I've already done the factors and I've already found a prime. So there's the 2 pieces of language that I've already started to see. It's even, so I'm just going to split it again by dividing by 2 and dividing by 2. 19 is prime. Now, product is the only word we've not used yet, and that means times. So we're going to put all these numbers together with a multiplication sign between them. You could write it as a power as well. Both would be acceptable. Your calculator actually has a factor button and it will do the work for you. It's 2 marks. I probably wouldn't risk it. I'd still do this, but I would use my calculator to check my answer, because if I have made a mistake, I'm going to find out and correct it and know I am absolutely guaranteeing those 2 marks. Your calculator actually does all of this work for you and produces this. So we've got to find the highest common factor of 96 and 152. And this again is where our calculators literally come into their own. I'm going to use the calculator to find my prime factors. I'm not going to do another tree and do another load of working out. Okay, I've set up my diagram. So I've got a Venn diagram. I've got my prime factors for 96, and I've got my prime factors for 152. And I'm going to marry up the ones that go together. So I've got 3 2s that can go in the middle. And then the rest go like this. Highest common factor is this section here. So it's 2 times 2 times 2, which is 8. If I'd been asked for the lowest common multiple, then I would be multiplying everything, all 3 sections, everything together. Okay, I've got to find the least value of x. Well, all I'm going to do is get x on its own to start off with. So I'm going to divide through by that 5. And then I've got x is greater than 7.6. It's greater than 7.6. So the least integer would be 8. Okay, I'm going to get the p's on the same side. I'm going to pick up the smaller set, and it's going to land as minus 3p. Why? Because on this side of the equals, I have got 3p. Now, I don't know what that number is, but I do know it's a positive number because there's no negative in front of it. And if I take a positive number carried across, it lands as a negative. So what I've now got is 5p, take away 3p. If I do that, it's going to give me 2p. I've still got my plus 10, and I've still got my minus 7. Now I'm going to continue to work on getting this on its own. So I'm going to take off 10, and negative 7 take away 10 means I'm going down the number line to minus 17. And then I'm going to divide through by my 2 to get p equals minus 8.5. Remember, you've got your calculator to help you with all of this. The one thing that I would say is when we got to this stage, some students really don't like this when it's kind of back to front. They're used to having this information on the left-hand side, and just this slight change can really mess with your head. You can absolutely 100% swap them round. Write the 2p plus 10 on the side that you like it. Just be careful when you do it that you don't lose any of the detail. Okay, we've got to describe the mistake that Tammy has made. Now, she rooted and then divided by 16, but she needed to divide by 16 first. I'm going to explain how you would know this. So when you're solving equations, you are actually doing BIDMAS backwards. And if we look at our equation, we've got the indice, so we've got this part of our BIDMAS, and we've also got the multiplication because 16 is squashed to the h, which means times. If we're doing BIDMAS backwards, we hit this first. So this should have been done first, indices second, and that was her mistake. Okay, we've got a percentage question, which we've got to wrap our heads around in a moment. The first thing we really need to do is look at the two costs. So the monthly ticket is 262. That's nice and clear and easy. No maths for us to do on that particular bit. But we do need to know the total cost of buying 20 separate tickets. So 20 times £15.70 gives us 314. So it's a pretty good saving. But let's work out what that saving is. So it's a saving of £52. What percentage of the total cost of 20, so the total cost of 20 is our 314, does she save by buying the monthly? And this is what she saves. So we're saving £52 out of that 314 that could have been spent. That's the fraction. You always times through by 100 to get the percentage. Our calculator is giving us this, on and on it goes. They want it to one decimal place, so 16.6%. And again, it doesn't matter what the context of the story is. If you're being asked to create a percentage answer, you will always start with a fraction first, always. Okay, we're writing 174 million in standard form. It might be nice to see the million, which would be 6 zeros, or you just start your count at 6. I'm going to show the whole thing. So that's my actual number. Standard form is one digit and then a point. So I am going to count from the end all these place values until I get to my point. So that's 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be 1.74 times 10 to the 8. Okay, we've been given the measurements of how thick a sheet of paper is and the depth in Mark's printer tray. First thing to note, really important, we've got millimeters for the tray and centimeters for the paper. We need to be in the same units. So we're going to change our millimeters into centimeters. So we've got 3 centimeters. We are then going to see how many 8.5s we can fit into our 3 centimeters. So 3 centimeters divided by 8.5 times 10 to the negative 3 into your calculator. And we get 352.94, on and on it goes. We needed to show that Mark can fit more than 350. We've done that. He can fit 352, nearly 353. Okay, so we've got a probability question. I do just want to talk about this word bias because I know that for some people, they're a little unsure of what that means. Bias just means that it's not like this equal chance between all the numbers. One might have a better chance. So if we look at our table here, the number 3 has got a probability of 0.32, which is a lot higher then the chances of getting a 1, which is a really small chance. The fact that these are so different means that the dice is biased towards the 3. So it just means that it's not fair. It's not equally shared. It's not fair. It's biased. All right. Now, it's going to be rolled 400 times, and we've got to work out an estimate for the number of times the dice will land on 2 or on 5. So the probability for 2 is 0.15, and for 5, it's 0.24. So together, that probability is 0.39. I'm going to take that probability, multiply it to the number of times it was actually rolled to get my estimate of 156. So out of the 400 rolls, 156 of them we would estimate to be a 2 or a 5. Okay, so this question went across 2 pages. So what I'm going to do is just keep the scatter diagram displayed, because that's where we're going to get our answers, and then I'll just jot them down in the margins. Now, the first question was to explain how we can see from the scatter graph that he ran a slower speed on one of his particular training sessions. The way that we can identify that is here. This one is not really running in line with the rest of the data. This is all kind of showing a pattern, whereas this one really doesn't fit it. It's called an outlier, and we might as well use that word to help us make that explanation. So we know because it is an outlier. Okay, the second part to that is on this training session, what distance? So we're looking at that outlier and we are going to work out the distance. So we're just going to drop straight down and work out exactly where that is. Now you have to be really careful and check that what you think is happening is actually happening. So I've got 5 here and 10 here. If I go up 1, I'd go 6, 7, 8, 9, 10. Well, that doesn't work because 10's all the way over there. So maybe I'm going to go up in 2 squares. So that would be 6, 7, 8, 9, 10. And that does work. So the answer is 8. So just be really, really careful when it comes to those scales. We've got to write down the gradient of the line of best fit. They've given us the equation y equals 4.6x plus 9. And from that, they want us to write down the gradient. The gradient is always the number squashed right next to the x, always. So our gradient, well, the answer that they want is 4.6. Okay, so we've just worked out the gradient is 4.6. Now we've got to describe what that represents. So we need to really kind of think about this. A gradient is how steep a line is. And we usually find this using a formula where you're doing your rise over your run. Now, if we just take a look, our rise, if I was to put a triangle, let's just say here, our rise is the time taken, and our run is the distance. So we've got a rise, which links to time, and a run that links to distance. We've already worked out the gradient from the equation is 4.6. If I put that over 1, I'm not changing the value. It's still worth 4.6. But now I've got this rise over run. So I am traveling 1 kilometer in 4.6 minutes, which puts me there. All right, so we're going to be comparing the normal price of the tickets. So we've got to find the normal price for both Anya and Leon. So let's think about Anya first. When she bought her ticket, it was 1/3 less than the normal price, and she paid 135. So this 135 represents 2 thirds because a third was taken off to leave us the 135. What I want to do is work out what 1/3 is, because then I can take it back to 3/3. I can take it back to the whole, to the original cost. So if this 135 is representing 2/3, if I divide through by 2, which gives me 67.50, that is a third. If I times by 3, I'll get £202.50, which is 3/3 or a whole. That is the total full normal price. Now we're going to do a similar thing, but this time we're working in percentages, not fractions. So Leon paid 126, and that was 40% off. So the 126 is 60% of the original. If I divide through by 6, I'll get 21. That is 10%. I want to get to 100, so I'm going to times through by 10 to give me £210. Now, you might have decided to divide through by 60 to get 1%, times through by 100. How you manipulate this would be what you naturally see. But if I can get to 10%, that's usually quite a good place to go. Now I can make my comparisons because I've got the normal price for both. Anya is saying that her ticket was less than Leon's, and she's absolutely right. It was. So we're going to answer the question with a yes. Okay, so we're being asked to factorize. It's 3 terms, so 2 brackets. I'm going to drop the x. It starts negative, which means I flip, change to the opposite if you like, and I put a negative in there. And my how-to video explains how all of this works. It's quite a nice little way of doing this because you don't have to think quite so hard. So we're looking at 2 numbers that multiply to make 20. 4 and 5 do. 4 and 5 will also make me the 9 that I want. I've already got the fact that it's going to be 2 negatives, so I can just pop them in and just make absolutely sure. -5 minus 4 makes -9. So that is my factorization of the quadratic we've been given. I would just say, if you wrote yours the other way round, absolutely fine. It does not matter. Okay, our last question. We've been told that there is symmetry within this diagram. So I think straight away I would be doing that. I know for a fact that's got to be 17, so I'm putting it on there so I don't forget. I've got to calculate the perimeter. So my problem really is this entire length here. I don't know what it is. I've got to find a way of working it out. I can see that it mirrors some of this edge up here. So what I could do is just drop down, and I now know that this kind of middle section has to be 22.6. So I've got a little bit further with it. Because of the symmetry, I know that whatever this is, that must be the same. So I just need to really concentrate on what I've got going on just the one side, and it'll be the same. What I've created here is a right angle triangle. And I'm just going to bring that right angle triangle out away from the diagram so I can see it clearly. There's my right angle. There's my 17. I do know this edge because they've told us here in the diagram that the height is 15, which is great. When I've got 2 edges in a right angle triangle and I need to find the third, I'm going to use Pythagoras. Pythagoras is on the formula sheet, so make sure you're using that. And it's a squared plus b squared equals c squared. A and B are the 2 edges that make the right angle, or you could think of it as the right angle pointing to the 2 edges. So if I look at those 2 edges, I have got 15 on one of the edges, so that can change to 15 squared, but This one, which we can now call B, is missing. So we'll keep it as B, and the unhighlighted edge is our hypotenuse. It's our longest edge, is our 17. I want to work out what B is. So I'm going to take this 15 squared and move it across, and it will land as take away 15 squared. If I do 17 squared, take 15 squared into my calculator, I get 64. So my B squared is now equal to 64. I want to square root, and now my B is equal to 8. So I know that that is 8, which means that is 8. I can now add all those edges to get my final answer, which equals 95.2 centimetres. So not a bad little paper, definitely some tricky ones in there. Hopefully I have explained it all well enough for it to make sense. And hopefully if there are errors in your paper, you've been able to learn a little bit from watching the video. Paper one's already done, it's out there. Mock set 7, paper 3, we will start work on that, and hopefully that will be with you in the next few days. If you are finding these videos useful, it would be great if you hit the like and the subscribe button so you don't miss any of our videos. We are making practice videos right the way through to the summer exams. There's going to be so many available for you.